Sakshi from Ask IITians, and today I will be telling you how you're going to solve the questions which were asked in this year JEE mains. So I'll be trying to tell you what were the mistakes that you could have done and what are the facts that you need to keep in mind so that your JEE advanced paper goes well. So without wasting any further time, let us come over to the very first question that we have. Now this question that has been given to us is basically from the chapter hydrogen. Now once you are doing the question from this chapter hydrogen, the options that have been given to us in this question are, like, you have to tell which is the false statement among all the options which are given to you. And if I ask you to go for the options one by one, the very first option that has been given was that the ice which is formed by heavy water sinks in the normal water. So let me write down that when you have ice which is nothing but water, but he has given heavy water, so be very clear that he is talking about D2. And it says that it is sinking in the normal water. So if it is added to the normal water, it will sink. And students, this is a very easy question. Yes, because the density of heavy water is greater than that of normal water. So this option that has been given to us is correct. But we were to identify the false statement. Coming over to the second statement, and that is water is oxidized to oxygen during the photosynthesis. And if you go for the photosynthesis reaction, you can write down the equation. So we know this basic equation that water is getting oxidized to oxygen in this end. So this option is also correct. But again, keep in mind, we have to find out the false statement regarding the same. Now coming over to the further third option, it says that water is acting both as acid as well as base. And this is a fact that water is amphoteric. It can act both as acid as well as base. But the fourth option which is given to us, there is extensive intramolecular hydrogen bonding in the condensed phase. So my dear students, whether he has written condensed phase or any other liquid phase, you need to keep in mind that he has referred to intramolecular. See, you could have done this particular mistake in the question. Intra means within the same molecule, but how can water have intramolecular hydrogen bonding? So this is the false option for this question, and hence we can say that out of B, C and D, so this D is the correct answer because we were to give the false statement. So this is the one common mistake which students do in the exam. So this was the answer for this particular question. Now let us move over to the next question. So students, now let us come over to the second question that we have. The question that has been given to you was that you were given the concentration of, see, I'll be writing the ions of which the concentration was given. So he said that the concentration of fluoride, lead, nitrate and iron which have been given in a water sample from an underground lake was found to be, so I'll be writing the concentrations. So for fluoride you have been given 1000 ppb. For lead you have been given 40 ppb. And for this you have been given 100 ppm. And for this you have been given 0.2 ppm. So this water is unsuitable for drinking due to the high concentration of which. So students, for this thing you should be very careful that the question has been asked from that particular topic environment. So chemistry in everyday life, it includes the concentration of all the particular ions in given water which can be made useful for drinking, right? So you have to tell the water which is unsuitable for drinking, like any particular water. So you can very easily say that sample of water which has got a greater concentration of ions as per the expected value will be found to be unsuitable for drinking. And if I am not wrong, you must be aware that for iron, the maximum concentration that has been given to us is nothing but 0.2 ppm. So this is the maximum concentration you need to keep in mind, and hence this is the correct option. So this can be suitable for drinking. But for fluoride, the concentration should be 1.5 ppm. So this is also less concentration, and hence this can be also suitable for drinking. Now coming over to lead. So if I am not wrong, for lead the maximum concentration is only 50 ppb. And for nitrate, again the concentration is 50 ppm. So be very careful. These are the points where you could have done the question wrong. You should be very careful why some ions are found in the concentration maximum of ppm and others are found in the concentration of ppb. So keeping all these points in mind, you can very easily say that out of this, nitrate has been found to be more as compared to the expected value, and hence the water containing this sample. So let me see for the options. Nitrate is option number 4. D option is the correct option for this particular question. So students, now let us come over to the third question, and the third question says that galvanization is applying a coating of which particular element. So a very basic thing in this chapter. Now this question can be either taken up from the chapter extraction, or it can also be called as a question from the chapter electrochemistry, because in electrochemistry you have learned the techniques for saving the metal ions. So if I'm not wrong, you should be knowing this thing, that if you have iron, then to protect iron from rusting, you need to do a coating of zinc. And the zinc coating over iron is done by the process which is known as galvanization. So we simply got the option as option number 1, because the option zinc is given as option number 1. So this is the correct option for this particular question. Also keep in mind the basic fact that has been used for this question, and that is the difference in reactivity of iron and zinc. So once iron is coated with zinc, it becomes less reactive because of the coating of zinc over the iron, and hence it will not be in direct contact with the atmosphere, and hence you can say it is being protected. So students, learning this concept also, I think you have got the answer for this question as option number A. Let's come over to another question now. Now the question that has been given to us, the question number 4, this question has been asked from one of the very important chapters, and that is coordination chemistry. So if you have done this chapter coordination chemistry in details, it would have been possible for you to do this question. Now let us look into the solutions. The question says, which one of the following complexes shows optical isomerism? So the options which are given to you are CO, NH34, Cl2, Cl. Then option number 2 is CO, NH3 thrice Cl3. Then you have cis, cobalt, ethylenediamine twice Cl2Cl, and the fourth option is trans, COEN twice Cl2Cl. So students, any particular option which would have got non-superimposable mirror image will be the correct option for this question, since you have to tell the option which is good for optical isomerism. Let us take into account all these options one by one. So if I look into this option, the first option, CO, then you have, since it is hexa coordinated, you have to arrange 4 ammonia and 2 chlorines. So suppose I arrange 4 ammonia in the plane of paper, and if I arrange 2 chlorines, one above and one below the plane of paper. So if this is the plane of paper, this is the front half and this is the bottom half, and hence it has got a mirror image, or it has got a plane of symmetry, and hence it will not be optically active. Coming over to the second question, so this is CO. Again I will say 3 ammonia and 3 chlorines are there. So if I place 3 ammonia here, and if I place 3 chlorines here, so the basic thing that you have to keep in mind is to find if there is any plane of symmetry, because the question says which shows optical activity. Now in this particular complex, it has got optically 2 inactive isomers, because there is also a plane of symmetry. So either I can write it like this, or I could have written it like this. So if you look here, you will find that this molecule has got a plane of symmetry, and hence this is also not optically active. Coming over to the third option, you have got cis COEN2Cl2. And if he's talking about cis compound, I will say cobalt here. Now if I keep one En here, another En here, and this is Cs here. Now if this is the main compound, you can also draw the mirror image. And the mirror image will be drawn this, Cl and Cl. Now since these two are non-superimposable mirror images of of each other, and hence I can say that cis cobalt ethylenediamine twice Cl2Cl is the correct answer for this particular question. So students, be very careful whether he is referring to the cis isomer or the trans isomer. If you consider the trans isomer, there will be again a plane of symmetry. So the basic hint is look for the plane of symmetry. If there is any plane of symmetry in the molecule, it will not be optically active. So fine with this question. Now let us move on to the another question. Hey students, coming over to the another question. Now this question has been asked from the chapter States of Matter, one of the most important chapters. Now let us go for the question. It says that you have two closed bulbs of equal volume that have been containing an ideal gas which is initially at pressure Pi and temperature T1. So let us say there are two bulbs. So initially this has been given at a pressure Pi and the total temperature is T1, and this is also at a pressure Pi and the temperature is T1, and they are connected through a narrow tube of negligible volume as shown in the figure. So we have drawn the figure. Let us now consider that the volume here is V and here also the volume of the container is V. Now he says that the temperature of one of the bulbs is then raised to the temperature T2. Now let us say this was the initial condition, and if I go to the final condition, then also let's say the bulbs are the same. So let's say here, so there will be a change in pressure PF, and let's say this is at temperature T1 but the volume will still be same, and here also let's say the final pressure. Now see, since both the bulbs are connected through the same tube, so the pressure has to be the equilibrium pressure which will be same in both the bulbs. Temperature is T2 and let's say the volume is V, and this is the final condition. Now you have been asked that the final pressure PF is. So you have been given certain relation and you need to find out what is, which is the correct statement or how you are going to calculate the final pressure. So if I am not wrong students, see the hint I will give you for the question. Just calculate the number of moles of the gaseous species present in this container as well as in this container. Let us say N1 plus N2. You have to equate it to the total number of moles present here, N1 plus N2 dash. Now if you know this, right, using the ideal gas equation, which is nothing but PV is equal to nRT. So you can very easily say N is equal to PV over RT. Substitute N1, N2 in the terms of initial pressures and volume. Similarly substitute these N1 dash, N2 dash with these things, and hence you will get the answer. So the common mistake which students could have done in this question is taking, if he has given Pi, see he didn't give anything regarding what is the pressure here. But keep in mind, since they are connected together,